So in this segment, we're going to look at evidence that we have two systems by which we reason. We'll start with the experiment dealing with cards. You filled this out last class. So there's these four cards, and the psychologist, or in the case of our class, me, says, here are the four cards. Each has a letter on one side and a number on the other side. I want you to choose only those cards necessary to determine whether the following rule holds. The rule is, if a card has a vowel on one side, then it has an even number on the other side. So again, the rule says if a card has a vowel on one side, then it has an even number on the other side. And your task is to figure out which cards you need to turn over to test whether that rule is true of these four cards. Here's the results. About 80% of people say A and 4 are the two cards you need to turn over. The cognitive psychologist measures that and sees that's how people are disposed to respond. But in fact, that answer is wrong. So along comes someone who's going to tell us what the right answer is and why it's the right answer. And here's what the rule says. If the card has a vowel on one side, then it has an even number on the other side. And now what I want you to do is look at each of these cards with the rule in mind and think about the cards one at a time. So the rule says if vowel, then even. Well, what does if vowel, then even mean? It means that there can't be, that there's not, and this symbol here just is another way to write the not, that there's not a card that has a vowel on one side and an odd number on the other side. So the rule, if vowel then even, only requires this, that there is not a card with a vowel on one side and an odd on the other. So let's take card A, and imagine on the opposite side of card A there's a 2. Does that violate the rule, if vowel then even? Well, the only way you can violate the rule, if vowel then even, is by having a pairing of vowel and odd. And A and 2 would not be a pairing of vowel and odd. So you don't need to worry about that possibility. What about the possibility that there's a 3 on the other side? Would that violate the rule, if vowel then even? Well, again, the only way you can violate the rule is by having a pairing of vowel and odd. Would A and 3 be a pairing of vowel with odd? Yes, indeed it would. So you have to turn over card A to make sure it doesn't have an odd number on the other side. Because if card A has an odd number on the other side, then you've violated the rule. What about card C? Well, C with 2 is not a pairing of vowel and odd. C with 3 is not a pairing of vowel with odd. So it's impossible to have a pairing of vowel with odd regardless of what's on the opposite side of card C. So you don't need to check card C because no matter what's on the other side, it's going to be consistent with the rule, if vowel then even. What about card 4? Well, this is one of the things people often pick. Do you really need to check it? Well, what you need to do is ask yourself, is it possible to have a pairing of vowel with odd? So let's suppose there's a vowel on the other side, that there's an A. Is that a pairing of vowel with odd? No, because 4 is even, so 4 and A is not a pairing of vowel with odd. What if there's a B on the other side? Is that a pairing of vowel with odd? Well, no, it's not. 4 is an even number, B is a consonant, but that's not a pairing of vowel with odd. So regardless of what's on the other side, you don't have a pairing of vowel with odd. So regardless of what's on the other side, you haven't violated the rule, if vowel then even. So you don't need to turn over card 4 because it doesn't matter what's on the other side. It can't violate the rule. What about 3? Well, if you have an A on the other side, that is if you have a vowel on the other side, then you have a pairing of vowel with odd and you violated the rule. So you do need to turn over card 3 to make sure it doesn't have a vowel on the other side, because if it does have a vowel on the other side, then it violates the rule, if vowel then even. So A and 3 is the correct answer. Now, why do the majority of people pick A and 4? And why does only a small minority pick A and 3? Well, the reason most people pick A and 4 is pretty straightforward. Regardless of what story you tell yourself about why you pick what you pick, here's what's going on. System 1 is screaming at you A and 4. Why? Because System 1 cares about superficial similarity. And A is a vowel, 4 is even. The rule mentions vowel and even, so System 1 is like, pick the vowels and evens. It likes that simple task, pick the vowels and evens. It ignores what the logical relation actually is and just says, do this simple task, pick the things that match. And that drives most people, leads to their judgment, leads to them picking A and 4, when in fact the correct answer is A and 3. Okay, so I'm going to just reiterate this, since we see the words vowel and even in the rule, we look for vowels and evens among the answers and choose the appropriate cards. What's the lesson? Well, most people initially choose A and 4, which shows that we have a system 1 and that it influences our judgment, and it makes judgments based on similarity. The fact that we can overcome this and understand that the correct answer is A and 3 shows that we have a system 2, shows that we can do some rule-based reasoning. Okay, next example, the conjunction fallacy. This is the Linda example. So here you're given the stimulus, which says to rank the various possibilities related to Linda from most probable to least probable. Linda in the description is described as having been active in social justice movements in college, having been active in anti-nuclear demonstrations, and then you're given this list. And the list includes a variety of options, but the two that are crucial for our purposes are just these. One option says Linda is a bank teller. Another option says Linda is both a feminist and a bank teller. Now, the vast majority of people say that Linda is both a bank teller and a feminist is more probable than Linda is a bank teller. Well, that has to be wrong. Why does it have to be wrong? Here we have a depiction of the space of bank tellers. This is all the bank tellers in the universe. And here we have a depiction of the space of feminists. This is all the feminists in the universe. Maybe these circles overlap a bit more, maybe they overlap a bit less. For our purposes, all that matters is they don't have exactly the same members. They don't overlap perfectly. That is, there are some bank tellers who are not feminists, and there are some feminists who are not bank tellers. Okay, why does that matter? Well, if you say that it's more probable that Linda is both a bank teller and a feminist, then you're saying it's more probable that she's in this space right here, the bank teller and feminist space, than it is that she's in this space right here, the bank teller space, which includes the feminist bank teller space. So you're saying it's more probable that she's at some particular point in the bank teller space than it is that she's either at one of those points or at one of the other points. Well, that has to be wrong. It has to be more probable that she's either over here somewhere or over here somewhere than it is that she's just over here somewhere. That is, it has to be more probable that you're somewhere or other in the space of bank tellers than that you're in this particular subset of the space of bank tellers. And so it must be more probable that you're a bank teller than that you're both a feminist and a bank teller. Well, why do we say otherwise? Why do we pick bank teller as more probable than both feminist and bank teller? Sorry, why do we pick both feminist and bank teller as more probable than just bank teller? It's simple. System 1 is screaming at us, pick feminist. System 1 says, look, Linda is more similar to a feminist than she is to a bank teller. I see the word feminist in this reply. That means rank it as probable. All System 1 cares about when assigning probabilities is superficial similarity. It says feminist is more superficially similar to social justice activist and anti-nuclear activist than those are to bank teller. So pick feminist, pick the thing with feminist in it. It's just screaming at you to do that. And rules of probability, objective facts like it has to be the case that one thing is more probable than the conjunction of that very thing with something else, get thrown out the window. Of course, the fact that we can recognize that being a bank teller is more probable than being both a feminist and a bank teller when we slow down and think about it demonstrates that we have a system 2 that can assign probabilities based on rules. Okay, so this is evidence that we have two systems of reasoning. System 1, the automatic system, says the probability that someone is a feminist and a bank teller is greater than the probability that the person is just a bank teller. But System 2 says, no, the probability that someone is a bank teller is greater than the probability that they're both a feminist and a bank teller. And of course, System 2 is getting the right answer in this case. Okay, let's look at the next example here. This is an example dealing with argument strength. When subjects are told to rate the convincingness of the following argument on a scale from 0 to 10, 0 being not at all convincing, 10 being entirely convincing, and then given the following argument, all birds have an ulnar artery, therefore all robins have an ulnar artery, subjects rank it as highly probable. But when they're given the argument, all birds have an ulnar artery, therefore all penguins have an ulnar artery, they rank it as a bit less probable. So specifically, they give 9.6 and 6.4. Why does that matter? Well, this holds even for subjects who affirm robins are birds and also affirm penguins are birds. So they agree all birds have an ulnar artery, penguins are birds, therefore penguins have an ulnar artery. But they say that's less convincing somehow than all robins have an ulnar artery, robins are birds, therefore all robins have an ulnar artery. Well, the arguments have the same exact logical structure. Since they have the same exact logical structure, and subjects affirm that each premise is true, they ought to rate them as equally convincing. But they don't. Why don't they rate them as equally convincing? Because system 1 doesn't like all penguins have an ulnar artery, penguins are birds, therefore all penguins have an ulnar artery, because it doesn't like that penguins are birds. They can't fly. They're not superficially similar to paradigmatic birds. So it's screaming at you, that's a bad argument. There's something funny going on there. Rate it lower. But of course, it's wrong to rate it lower because the arguments are exactly identical in terms of their convincingness. So this is just going through what I just said, a sense of the prototypical drive subjects' responses, but we know that both arguments are equally convincing because they have the same logical form and both have all true premises. And again, even subjects who agree that they have the same logical form and that both have all true premises rate the robin argument as more convincing than the penguin argument. Okay. So the fact that we can recognize that both arguments are equally convincing suggests that we have a rule-based system, but the fact that we initially rank the robin argument as more convincing than the penguin argument suggests that we have an associative system along the lines of system 1 and that it pushes us around when we're using system 2. Conclusion, we have two systems of reasoning. Now there's some slides here that run through how neural nets work. I'm not actually going to talk these through. They're just there if you want to look at the slides and read them and get from them what you get. This is an example of detecting a mine versus a rock and how a neural net can learn to do that. Again, if you want to look at these slides, you can just go look through the slides yourself rather than having me talk you through them. They're not going to be on the exams or anything. Neural nets, by the way, are similar to System 1 style processing. Okay, we'll stop there.